Yes, good afternoon, everyone. It's an honor to speak in front of this lovely ClueCon community. So last time was the first time I spoke at ClueCon, and it only compels me to do it every time going forward. So today I'm going to talk about unleashing the power of AI and ML in telephone security and analytics. So I'm going to specifically focus on the voice biometrics and transcription use cases. So this is the last talk for today. Not the best time to have one, so bear with me. So to introduce myself, I'm the proud father first, then a lovely husband, passionate about the real-time communication solutions. I'm the co-founder and CTO of ecosmob. So ecosmob is a software development company specializing in real-time communication solutions and your preferred technology partner. We have close to 300 employees in India, and over the course of 16 years, we have served more than 600 clients and completed thousands of projects successfully. As our dear friend Jeff mentioned, there are most of the stuff in life that you can't outsource. Thankfully, software development is not one of them. So we specialize in real-time communication, solution development, web, mobile, AI, ML. We also offer services like DevOps, quality assurance, and support. So that's a very quick, brief intro about myself and the company. Let's jump into the use cases. So the first case I want to talk about is the voice biometrics. So there are a lot of solutions out there already. So why would you want to build yourself? Why to reinvent the wheel, right? So see, this is one of the use cases that we are targeting for our client. There were several challenges with that. First is the solution that they were using. It was highly dependent on the exact phrase that was used during the enrollment of the user. You have to use the same phrase and language while doing the verification. The data was also stored on the provider's cloud, which can be a challenge and concern at times. See, most of the times you want to do it yourself because of the regularity and compliance issues. Otherwise, you can as well directly use the cloud services. And of course, there are per verification charges. So how we try to address those is we try to make sure that there is no dependency on the language as well as the phrases. You can literally say anything during the enrollment and at the time of verification, and it should directly work seamlessly. Then we also wanted to verify and make sure the audios, even in the noisy environments, they also work seamlessly without any issue. And then we validate with the minimal audio duration so that the verification process is extremely fast. So So we analyzed a lot of toolkits, models, and libraries available in the market these days, and we shortlisted these two, SpeechBrain and NVIDIA NeMo. So when we compared both of these, we realized that in order to get the speaker embeddings, first of all, you have to load the audios using the Torch Audio library, and then normalize it and encode it before we get the embeddings for SpeechBrain. While in NVIDIA NeMo, you can directly get the embeddings from the file. So because of that, NVIDIA NeMo was performing 3x faster in order to get the embeddings. Then the confidence score for the NVIDIA NeMo was also higher. It was 0.7 compared to 0.39 of SpeechBrain in our tests. And because of that, we are also getting higher accuracy for NVIDIA NeMo. So we continued our tries with NeMo toolkit. So first what we did is the first approach that we took and didn't work very well, we failed miserably, is this one. So what we did is when we enroll the user, we get the speaker embeddings, we save in the single file all the users. So, and at the time of verification, we get the audio recording, then we get the embeddings, and then we compare that with all the embeddings of all the users in the file. Then we figure out what is the maximum score, which file, which user met the maximum. Then we compare it against the threshold that we have set and is configurable, by the way. So if it is there, then we identify the speaker. So we ran into several limitations with this approach. So let's say if the speaker is, the user is not registered, then the audio still tries to match with the other users, and there is a chance that it may have the false positives. We can have incorrect acceptance, false acceptance rate, and the user could be identified with someone else because at the end of the day, it's all the mathematics, formulas, and calculations, right? So we realized that, and then we tried to change the approach. So in the new approach, what we do is, basically this process is divided into two phases. First is the enrollment phase, and second is the verification. So for enrollment, for each user, we get 3 to 5 audio sample recordings of 3 to 5 seconds each. So we don't need a very long recording, like 30-second one. The 3 to 5 seconds are more than enough in our taste. Then we ensure there is a voice activity in the samples. So the silence is not permitted, which is an equivalent of no passwords, basically, because that is, you can easily reproduce, right? So we verify the voice activity and reject the silence audio recordings. Then when the user gives all the samples, we compare each and every sample with each other with the cosine similarity. And we ensure that all these samples belong to the same user. And then only we store those embeddings into that particular user's database only. So that is how we store and do the enrollment of the users. Now, for verification, now instead of comparing with all the users, first we identify the user directly. So instead of changing from the primarily authentication method, we made it like a two-factor authentication. So, passwords and PIN can be easily shared, but it's tough to mimic the voice unless, of course, generative AI does that. So after verifying the user with the PIN-based authentication, then we ask the user to say something, literally anything. It doesn't have to be the same phrase that they did at the time of enrollment. And just 1 second of audio is enough. You don't need a very long duration file. Then we again verify the voice activity. It should not be silence. And then we compare that recording embedding with the ones stored for the same user, with each and every embedding that we had. And we take the average score out of it. Then we compare that with the threshold. And if it is matching, then only we validate the user. So that gave us very good accuracy and performance. So if we talk about accuracy, we did some more tests with thousands of samples. As you can see, we tested with 2,886 samples, and out of that, 2,870 were correctly verified, either positive or negative side. And as I mentioned earlier, it is supposed to work with any language and any phrase. So I also even tested with my daughter's recording at the time before she started speaking or talking. And it was working flawlessly. It was something like this. Oh, there's no audio. OK. OK, so that's the name she has given me while she was 6 months old, and she still keeps calling me with the same name. And as you can see, there was background activity as well in that recording, and it was still working flawlessly. If we talk about performance, we took this Intel Xeon processor with 2.50 gigahertz speed and 4 CPUs and 16 GB RAM. Note that we didn't use GPU yet, and it is still working fine. As you can see, in terms of enrollment, which doesn't have to happen often. So one request takes hardly little over a second. And if we are doing it parallelly, which is again not an activity that is going to happen often, we did 1,000 requests in 1,270 seconds or so. And the validation request, one request hardly takes 0.34 seconds, 348 milliseconds. And if we do 1,000 at the same time, it hardly takes 195 seconds. So it's very, very quick. So what we get here is, it is independent of the language, independent of the phrase, works on the CPU, avoids the false positives, and it is extremely fast, so that it doesn't add delay to the call. Now let's talk about the second use case, that is the transcription. So here we didn't want to send the audio out to the provider, and that's why we decided that we should have the on-prem, on-server solution, and that's why we tried to build the transcription engine using the open source components, of course. So what we focused on is one of the challenges that we realized that in the audio recordings, there is a possibility that people can talk multiple languages, can speak multiple languages in the same call, in the same conversation, even in the same line. So it should be able to detect and identify those words properly and then transcribe properly. And we also wanted to ensure that two-way calls are there, so proper channel sequence should be maintained. And then when we look at the recording, the transcription, it should come out well. And there should be high confidence score for the language detection, so we don't have false languages, as Joe mentioned earlier. So we considered several solutions out of those available. As we learned earlier, there are many of them. So we analyzed these 4 of them: WASC, Facebook Wave2Vec, NVIDIA NeMo, and OpenAI Whisper. So NeMo and OpenAI Whisper seemed more promising compared to all of that. While NeMo performed much better than WASC and Facebook Wave2Vec in terms of speed and accuracy, but it had some trouble with the noisy environment and overlapping audio. So if 2 users are speaking at the same time, or if there is a lot of background noise, it wasn't giving a good accuracy. Yes, you can remove the noise, background noise from the audio file before doing the processing, but that unnecessarily increases the time complexity and reduces the performance, right? So that's how and why we decided to go with OpenAI Whisper, which performs excellently in the noisy environments with a lot of background noise. So here, again, first approach that we took is, first of all, these are the audio recordings. We are not doing any streaming or real-time transcription. So we split the segment. We segment the audio into 2 different channels. Then we divided the audio into 1-minute chunks, fixed 1-minute chunks. Then we identify the language of each chunk. So the first 30 seconds of those chunks is used for identifying the language. And for the rest of the chunk, the same language is assumed, and this model uses that language to transcribe that particular chunk into the text. And then we arrange these utterances in the proper sequence and prepare the transcription. So we face, again, a lot of challenges here with this approach, because first of all, the OpenAI Whisper model is quite bulky. It requires so much processing power and memory. And if we are doing it concurrently, it's going to add a lot of lag to the audio files, I mean, to the transcription process in general. So we did a lot of further research and try to find out what is the best solution for that. So what we found is something called quantized model, called faster Whisper. So basically, it's the same model, but it's much smaller footprint, and according to their claim, it performs 4x faster than the traditional models. So here again, we improvised and modified our approach. So in this case, what we did is, first, after splitting the channel into 2 different segments, first we extract the utterances using the voice activity detection. Instead of the fixed 1-minute chunks, we look for the half a second silence. So whenever half a second of silence is detected, we split into different chunks. So each chunk has a different variable duration. And in those chunks, then we detect the language. And we use that language to transcribe that chunk. And then we organize the different text and prepare the proper transcription file. So we did the performance analysis with this faster Whisper and with the small model using the Intel Xeon same processor, basically, 16 gigs of RAM. But for transcription, we did use GPU. You can't do it on CPU easily. It's very, very difficult, even on GPU. And this is the kind of performance and statistics we got. So in order to do 1-minute file, it took like 8 seconds. And for 1-hour file, it was taking like 136 seconds. Then we also tested it in batches, and at somewhat scale, not full scale, but as per our analysis, the use case that we are working on, we realized that at the moment, at the same time, around 20 call recordings will be generated. And that can be of the different random durations. So what we did is we create a batch of 20 files, each with different duration ranging from 1 minute to 20 minutes. So the total duration of those files of those batch is 210 minutes. And it took 165 seconds to transcribe all those files. So that's not the perfect solution, and we are still working on it. So there are limitations. There can be more scope of performance improvement. That's a further research topic that we have. So we are going to focus on improving the performance of the single transcription first. Then we are also going to focus on getting the word level confidence and make it interactive transcription with the visualized confidence scores. So when you hover over a particular word, you will know that what exact confidence score is that for that word and how much you can rely on this particular transcription. So that empowers you to make a better judgment whether to rely on that as a whole or as a particular word you can ignore, or you need to go back to the file and listen to it in order to make sure what they are speaking about. The current model that we are using, as Joe mentioned, supports hundreds of languages, but not perfectly. There are hardly, we identify top 10 languages or 5 to 10 languages that supports is English, Spanish, Portuguese, German, and a couple of more. So we would not rely on it much and make it available for all the languages. But majority of the language that we were going to focus on is English and Spanish, so we are good for now. And then again, this is just the recorded audio transcription, and we should be doing the real-time transcription also in case we want to transcribe the active calls and we want to make it available as a live view. So that is something we should focus on. So I have one quick live demo. So in this demo, what we are going to do is first we'll do the enrollment of the user. Then we'll verify the user, how it works. And then we'll have some dialogue with the IVR that is hosted somewhere else. And then I'll have a dialogue with the IVR, and that particular dialogue will be transcribed. Okay.
Press 1 to enroll yourself. Press 2.
What is your first name?
Ruchir.
What is your last name?
Brahmbhatt.
What is your hobbies?
Music, reading, listening to music, movies.
Enrollment successful. Please authenticate yourself.
Strongest Avenger.
Your voice is verified successful. Hello. May I know who is speaking?
Yeah, this is Ruchir Brahmbhatt.
Tell me something about yourself.
Well, I have came from the future to warn everyone. I am here to stop Skynet from happening.
Thank you. Have a nice day.
So yeah, this is the transcription that we got. Let's see how accurate it is. Oh, not great. We have to work on it, but yeah. It works. There is a scope of improvement. So I put some reference links for further study in case you need it. And with that, I conclude my presentation and leave the floor open for any questions that you may have. Thank you.
Thank you, Ruchir. We do have time for questions. And we do have an appropriate... In fact, there's one from Max right at the back. OK, Max, go ahead.
Hey, thanks for interesting presentation. How do you deal with the replay attack? Somebody could just record the voice and play it back.
Sorry, I didn't get it.
How do you deal with the replay attack? Let's say I record your voice and play it to your system. Replay attack.
Play attack.
Replay.
So if somebody's recorded
Replay.
the voice.
Okay. Recording the same voice again and again. Is it so?
Yeah, I record your voice and I play
Okay,
to
you
your
record
system.
and play back. It's more like that deep fake or something, right? So it is handled as far as I know. I have to check with my team how well it is. But that's a very good input and feedback that we should double check and work on. Thanks for, that's a very good question.